Hi everybody, so today we're going to keep talking about solving trig equations. If you haven't seen part 1 of 2.3, you should definitely go back and watch it. This won't make a lot of sense without having watched that. Okay, so we're going to start with an example, and it's pretty similar to the example we started with last time. Okay, so to start this example, we're just going to kind of review what we talked about last time. So the first thing we do when we're solving something like this, we're just going to ignore the 2x for now. Okay, we're going to think about which triangle 1 over root 2 comes from, or if it's a quadrantal angle. So you should recognize 1 over root 2 is coming from the 45, 45, 90 triangle. Okay, and then we're going to talk about when the sine function is positive. Okay, there's two quadrants where the sine function is positive, quadrant 1 and quadrant 2. Okay, remember you can tell that by thinking about sine being related to the y coordinate, and the y coordinate is positive in the first and second quadrant. Okay, so we're going to draw our angle here. Sine is 1 over root 2. Okay, so this would be 1, and our reference angle would be pi over 4. Okay, so we're going to do the same thing in quadrant 2. Here we go. Okay, again, 1 over root 2 for sine. In this example, we'd had negative 1 here, okay, and our reference angle is still pi over 4. Okay, so in quadrant 1, okay, remember that means that our total angle is our reference angle. Okay, so our argument here, which is 2x, would be equal to our angle pi over 4. Okay, and we can just finish solving this by dividing both sides by 2. Okay, so far this is our only extra step, okay, is once you have the actual angle, you need to do one additional step to solve for, I didn't actually divide both sides by 2, there we go. So you only, so far, have to, once you set the argument equal to the angle you found, now you have to divide both sides by 2 to find x. Okay, so we're going to do a similar thing over here. We know that this angle here is going to be 3 pi over 4, so our argument is going to be 3 pi over 4. Okay, and then we're going to divide both sides by 2. Okay, so that's kind of a little review of what we did last time with this one additional step of dividing by 2 to get the final answer for x. Okay, so just hang on for a second because we are going to look at potentially the first coterminal angle. Okay, so for this column we had that our argument is equal to pi over 4, so let's look at our first coterminal angle. And remember, you get the coterminal angle by adding 2 pi. Okay, so I'm going to add those two together. That'll give me 9 pi over 4. Now, the reason we weren't looking at this answer before is because 9 pi over 4 isn't between 0 and 2 pi. But look what happens when we divide both sides by 2. Now we have 9 pi over 8, and that is between 0 and 2 pi, right? 2 pi would be 16 pi over 8. So this, because we're dividing by 2, you can see it really is between 0 and 2 pi, so we would want to include this in our solutions. Okay, so let's do the same thing over here. We're going to look at our first coterminal angle. Okay, so we're taking our original angle, 3 pi over 4, and we're looking at our first coterminal angle by adding 2 pi. So I'm going to add these together. Okay, again, this is way bigger than 2 pi, but when we divide it by 2, okay, 11 pi over 8, that is between 0 and 2 pi. Okay, so you're getting these two additional solutions because you're dividing by 2. you're getting these extra solutions. So our final set of solutions would be pi over 8, 3 pi over 8. Okay, those are more traditional solutions. And then we have the ones coming up from our first coterminal angles, 9 pi over 8 and 11 pi over 8. Okay. Now the question is, how do we know that that's enough? Okay, and how would we know to even look at these first coterminal angles if I didn't suggest that? Okay, so I'm going to ask you to imagine the graph of sine 2x. Okay, now remember what happens when you have a 2 inside the function. Okay, this is going to shrink it horizontally. Okay, by 1/2. Okay, so we're going to look at the graph real quick. Okay. Okay, so here's pi over 2, here's pi, here's 3 pi over 2, okay, and here's 2 pi. All right. So, okay, since we're looking at the graph of sine, the y-coordinates for the key points are going to be 0, okay, and we're going to have shrunk the whole graph from 0 to 2 pi down from 0 to pi, okay? So here's going to be my key points that are on 0, okay, 1 and -1, okay, and then here's my okay. All right. And then we know that after that, the graph is going to repeat. So I would have exactly the same graph repeated again. Okay. Now, the reason that I wanted to look at this is to give you guys a good idea of why you're getting double the solutions. Okay. So when you're looking at 1 over root 2, okay, that's going to be somewhere in here. Now the first 2 solutions that we saw were this one here and this one here, and that's from the first rotation of the graph. Okay, but if you keep looking between 0 and 2 pi, right, we're extending all the way out to this line, you can see that those second solutions here and here, okay, those are coming from the second full rotation, okay, but it's still between 0 and 2 pi because of the shrunk down graph. Okay, now how do we know how many solutions there's going to be? Okay, well, we know there's 2 full periods here, okay, because of this 2. Okay, so this number is going to tell us how many solutions we're supposed to have. All right, so let's look at another example. So this is still solved between 0 and 2 pi, okay, and we're going to look at sine of 3x is equal to 1. Okay, now first we're going to ignore the argument and we're just going to solve sine of theta equals 1. Okay, so we're thinking about which perfect triangle or which special triangle has 1 as a sine, and none of them do. So then we're thinking this is probably a quadrantal angle. Okay, so remember sine is y over r. Okay, so we're looking for an angle where the y-coordinate is 1. Okay, so here's where my y-coordinate is 1. Okay, and this is my angle. Remember, we're setting our whole argument equal to this angle. This is pi over 2. Okay, now let's talk about how many solutions we should have. So solving using the traditional method, we would have 1 solution. Okay, now because of this 3, we're going to have 3 times as many solutions. So we should have 3 total solutions. Okay, now how do we find the other ones? Well, it's our coterminal angles. So we're going to look at our first coterminal angle, okay, and then we're going to look at our second coterminal angle. Okay, so here we're going to add these together. Okay, so this is going to be 4 plus 1 is 5 pi over 2. And here we're going to have 8 plus 1, which is 9 pi over 2. Okay, and now we're going to divide each of these by 3 to find our value for x. Okay, now here when you divide by 3, so you can reduce this. Okay. All right, and when you check these really are between 0 and 2 pi. Okay. All right. So remember we have 3 solutions because of this 3 here. You get 3 times the traditional solutions. All right, let's look at another example. Okay, still solve between 0 and 2 pi. Okay, so first we're going to solve this using traditional methods. Okay, so remember tangent is y over x. Okay, we know that in neither of the special triangles do we have tangent is 0. So we're looking at a quadrantal angle, and we want the y coordinate to be 0. Well, here's one point where the y coordinate is 0. Okay, so this would give us an angle of 0. Here's another point where the y coordinate is 0. So this would give us pi. Okay, so those are our 2 traditional solutions. Now, how many solutions should we have? We would have 4 times as many, or 8 total solutions. Okay, so we're going to look at, I'm going to leave myself a little bit more space here. We're going to look at the first coterminal angle here, which is 2 pi. Okay, we'll look at the second coterminal angle, 4 pi. Okay, we'll look at the third coterminal angle, 6 pi. Okay, and now you can see we have 1, 2, 3, 4 solutions that are all coterminal. Okay, we're going to do exactly the same thing over here. Okay, the first coterminal solution is 3 pi, then 5 pi, okay, and then 7 pi. Oops. Okay, and now we're going to divide them all by 4. So here you're still going to get 0. Here we're going to get pi over 2. Here we're going to have just pi, and here we'll have 3 pi over 2. Okay, so you can see these solutions really are 4 coterminal solutions for this traditional solution and 4 coterminal solutions for this traditional solution. So here I would have pi over 4. Here I'm going to get 3 pi over 4, 5 pi over 4, okay, and then 7 pi over 4. Okay, so even the largest solution, 7 pi over 4, is still less than 2 pi, okay? And we do have 8 total solutions. All right. Let's look at a slightly more complicated example where we actually have to do some steps before we're looking for the correct angle, okay? Okay, so let's look at this example. Okay, so before we get to talking about which angles we're looking at, we need to isolate the trig function. So I'm going to divide both sides by 2. Okay, and I get this. Oops. All right, now we're going to look for our traditional solutions, and we're thinking which triangle has root 3 over 2. So we know that that's the 30, 60, 90 triangle. Okay, and then we're thinking for which quadrants is cosine positive. Well, the first quadrant, all of the trig functions are positive. Okay, so my cosine is root 3 over 2, which would make this 1. And because the shorter side, this is the smaller angle, pi over 6. Okay, so for the other quadrant, you're going to remember that cosine is the x-coordinates. So I'm looking for positive x-coordinates, which would be down here. This is quadrant 4. Okay, so root 3 over 2. Now this side would be -1, but the reference angle is still pi over 6. Okay. All right, so now I'm going to have my 2 traditional solutions. Okay, pi over 6 from my first quadrant. Okay, and then here, right, 2 pi minus pi over 6, which is 11 pi over 6. Okay. Now, those are my 2 traditional solutions. I should have 2 times as many, okay, or 4 solutions. So I'm going to look at the first coterminal angle here. Okay, and my first coterminal angle here. So this is 13 pi over 6. Okay, and this is going to be 23 pi over 6. Okay, and then the last thing there is to do is just divide everything by 2 to find theta. Okay, so there's my 4 solutions: pi over 12, 11 pi over 12, 13 pi over 12, and 23 pi over 12. All right, let's look at another example that has that sort of solving. Okay, so again, I need to isolate sine before I do anything else. So I'm going to divide by 2. Okay, and I still have sine squared, so I'm going to take the square root of both sides. Okay, and I'm going to remind you not to forget about the plus or minus. Okay, oops, from my square root. So now we're going to simplify both sides. Square root of a square is just the radicand. Okay, and now we're ready to solve. Okay, so we're talking about 1 over root 2. Again, this is going to be the 45, 45, 90 triangle. Okay, now because we have the plus or minus, and we talked about this last time, it doesn't tell you which quadrant you're in. Okay, if sine could be positive or negative, that means you could be in any of the 4 quadrants. So let's just look at the first quadrant first. Okay, so here, okay, we have 1 and root 2. All right, so this is a pi over 4 reference angle. Okay, and this would give us the solution pi over 4. Then let's look at our second quadrant. 1 and root 2. Okay, this is a pi over 4 reference angle, which gives us our final angle of 3 pi over 4. Okay, looking at the third quadrant, now we're getting into our negative 1 over root 2, so this is negative 1 and root 2, still a pi over 4 reference angle, which gives us 5 pi over 4 as our final angle. Okay, and then our final quadrant, last solution, is here, negative 1 over root 2 with a pi over 4 reference angle, so this would give us 7 pi over 4. Okay, so this means we have 4 traditional solutions, okay, but we should still have twice as many. So for each of these traditional solutions, we need the first coterminal angle. Move that up so you guys can see it. Okay, so my first coterminal solution, 9 pi over 4. And then I'm going to do that for each one of these solutions. Okay. My last coterminal solution. Okay. And then to find x, I'm going to divide everything by 2. So here I'll get pi over 8. Here I'm going to get 3 pi over 8, 5 pi over 8, 7 pi over 8, 9 pi over 8, 11 pi over 8, 13 pi over 8, and 15 pi over 8. Okay. All right. So if you wanted to organize your solutions, certainly you could just circle them, or you could list them all at the end. Pi over 8, 3 pi over 8, 5, 7, 9, 11, 13, and 15. Okay. All right. So the last example I want to talk about is what if you have a fractional coefficient instead of a whole number coefficient? Okay. So here we go. All right. So first we're going to ignore the input and we're just going to solve sine equals root 3 over 2. Okay. So for root 3 over 2, we know we're talking about a 30, 60, 90 triangle. Okay. And when sine is positive, we know we're talking about quadrant 1 and quadrant 2. Okay. In quadrant 1, okay, if sine is root 3 over 2, this is root 3, this is 2, that would make this side 1, okay, and that would make this a reference angle of pi over 3, right? Larger side, larger angle. And here we're going to have the same thing, root 3 over 2, the side would be negative 1, and our reference angle would still be pi over 3. Okay, so that would lead us to do different solutions. Okay, pi over 3, Okay, and then this bigger angle, which is 2 pi over 3. Okay. Now, the logic we've been using, right, would say that we should have half as many solutions or just one solution. But let's look at what happens here. Okay, you can see 2 pi over 3 and 4 pi over 3, those solutions are both between 0 and 2 pi. So these solutions are both included. Why does that happen? Well, let's look at the graph of sine of x over 2. Okay, so this is going to stretch the graph out times 2. Okay. So instead of going between 0 and 2 pi, I'm looking at 0 and 4 pi. Okay. So my starting point is going to be here. My end point is here. Okay. My midpoint is here. Here's my maximum. Here's my minimum. Okay, so my graph is going to look like this. Okay, now if you're only looking at between 0 and 2 pi, you're only getting this part of the graph. Okay, so when you're talking about root 3 over 2, right, we're looking somewhere like this. Okay, and we're still going to get both of these solutions. Okay, now for example, if we were looking for negative root 3 over 2, okay, those solutions would be here and here normally, and if we were only looking at between 0 and 2 pi, we would actually get no solutions. Okay, so for the fractional coefficients like x over 2 or 1/3 x, something like that, you just find the traditional solutions, solve them, right, solve for x, and then find which ones are between 0 and 2 pi. Okay, all right. I hope that made sense. Feel free to come to office hours and ask questions or during our normal class time, and I will see you guys soon.